Ever wondered where comets come from? Let's dive into the mysterious Oort cloud. Picture a vast, distant, and icy sphere enveloping our solar system, a realm so remote that it stretches 1,000 times further than Neptune's orbit. This is the Oort cloud, named after Dutch astronomer Jan Oort, who first proposed its existence in the mid-20th century. The Oort cloud is theorized to be the birthplace of long-period comets, those celestial visitors that swing by our inner solar system after journeying for thousands, if not millions of years. The Oort cloud's significance extends beyond just being a cosmic nursery for comets. It's a key piece of the puzzle in understanding the formation, evolution, and history of our solar system. Imagine billions, perhaps trillions of icy bodies, remnants from the solar system's early days, preserved in the deep freeze of space. These frozen time capsules carry within them the raw materials that helped shape our planets, offering a window into our past. Every comet that graces our skies is a messenger from this distant frontier, bringing tales of a time when planets were just beginning to form. But the Oort cloud is more than just a collection of icy bodies. It's a dynamic and active part of our solar system. Influenced by the gravitational tug of nearby stars and even the Milky Way itself, objects in the Oort cloud can be nudged onto a journey towards the sun, becoming the brilliant comets we marvel at. The Oort cloud, a theory still under investigation, but a crucial part of our solar system. It serves as a testament to the vastness of space and the enduring mysteries it holds. As we continue to explore and understand the universe around us, the Oort cloud reminds us that our solar system is but a tiny part of the cosmic tapestry, woven with countless stars, planets, and indeed, comets. The Oort cloud didn't just appear out of nowhere. Imagine, if you will, the early solar system, a swirling disk of gas and dust. In this primordial soup, planetesimals, small, solid objects that would go on to form planets, were taking shape. However, not all of these planetesimals stuck around in the inner solar system. Some were flung out into the farthest reaches by the gravitational influence of the giant planets like Jupiter and Saturn. This is where the story of the Oort cloud begins. These ejected planetesimals, over billions of years, formed a vast spherical shell of icy bodies surrounding our solar system, almost a light year away. This is the theoretical origin of the Oort cloud, named after the Dutch astronomer Jan Oort, who first proposed its existence in the mid-20th century. Now, the concept of the Oort cloud is fascinating. It's not like the asteroid belt between Mars and Jupiter that's relatively flat and lies in the same plane as the planets. Instead, it's a spherical shell enveloping the solar system from all directions. This shell is filled with billions, perhaps trillions of icy bodies, remnants from the time of solar system formation. These icy bodies are made up of water, ammonia, and methane ices, and they're packed so far apart that they're more like solitary ships sailing in the vast ocean of interstellar space rather than a dense crowd. But what's even more interesting is that these icy bodies are not content just staying out there in the cold and dark. Every now and then, one of them gets a gravitational nudge, perhaps from a passing star or the Milky Way galaxy itself, and embarks on a long journey towards the sun, lighting up as a long-period comet as it gets closer. So the Oort cloud is like a giant, icy outer shell of our solar system. Now, where exactly is this icy reservoir, you may wonder? The Oort cloud, named after the Dutch astronomer Jan Oort, who first proposed its existence, is located far beyond the planets in our solar system. To give you a sense of its distance, if you were to travel at the speed of light, it would take you a year to reach the inner edge of the Oort cloud from the sun. This massive cloud of icy bodies stretches almost halfway to the nearest star, Proxima Centauri, existing in a region of space known as the outer solar system or trans-Neptunian space. It's so far out that it's unaffected by the gravitational pull of the sun, but is influenced by the gravity of nearby stars and the Milky Way itself. Now let's delve into the structure of this fascinating cloud. The Oort cloud is thought to be a giant spherical shell, almost like a bubble, enveloping our solar system. It's divided into two regions, the outer Oort cloud, which is a spherical shell, and the inner Oort cloud, which is donut-shaped. The boundary between these two regions is not distinct, and they overlap considerably. Imagine countless icy bodies, ranging from the size of small pebbles to mountains, all floating in this cloud. The density of these objects is thought to increase the closer you get to the outer edge of the cloud, making it denser than the inner Oort cloud. These icy bodies are the remnants from the formation of our solar system, preserved in the deep freeze of space. Their interactions, influenced by the gravity of nearby stars and galactic tides, can send them plunging into the inner solar system as long-period comets. So, the next time you look up at the night sky and see a comet streaking across, remember, it may have taken a journey of 1,000,000 years from its home in the Oort cloud to put on that spectacular show. The Oort cloud, a distant, dense, and icy structure at the edge of our solar system. It's a testament to the vastness and the mysteries of the universe that await our discovery. Ever seen a comet in the sky and wondered where it came from? Our journey takes us now to the long-period comets, the silent travelers from the distant Oort cloud. Long-period comets are a fascinating spectacle. Unlike their short-period counterparts, these comets have highly elliptical orbits that take them on lengthy voyages lasting anywhere from 200 years to millions of years. This is why they're known as long-period. They are also distinguished by their diverse inclinations, meaning they can approach the sun from any direction, not just the plane in which most planets orbit. But where do these mysterious icy bodies hail from? The answer lies in the Oort cloud, that colossal sphere of icy objects enveloping our solar system. It's believed that the Oort cloud is a vast reservoir of potential comets, with trillions of icy bodies, some of which are nudged by gravitational forces into the inner solar system to become long-period comets. These comets are essentially time capsules from the early solar system, preserved in the deep freeze of the Oort cloud. When they venture close to the sun, their icy nuclei heat up, causing gas and dust to spew out and form the beautiful, glowing coma and tail we associate with comets. It's also worth noting that long-period comets are the most likely culprits behind mass extinction events on Earth, due to their unpredictable orbits and potential for large impacts. They remind us of the dynamic and sometimes perilous nature of our universe. So the next time you witness a comet in the night sky, remember its incredible journey from the outermost reaches of our solar system. Remember the Oort cloud, the birthplace of these long-period comets. Long-period comets, the icy voyagers from the Oort cloud. Each comet carries with it a story of its origin, a tale written in ice and dust, all the way from the distant Oort cloud. Not all comets are the same. Indeed, comets come in two main types, short period and long period, and the primary difference between them lies in their orbits. Short period comets, also known as periodic comets, have orbits that take them around the sun in less than 200 years. They often follow the plane of the solar system and are believed to originate from the Kuiper belt, a region of space beyond Neptune's orbit. On the other hand, long-period comets have orbits that take more than 200 years to complete. These comets come from all directions, not just the plane of the solar system, suggesting their home is a vast spherical shell surrounding our solar system, the Oort cloud. The orbital characteristics of these comets provide us with clues about their origins, and by studying them, we delve deeper into the mysteries of our universe. Comets, each with their own unique journey. What causes these comets to leave their icy home, you may wonder? Well, let's dive into the world of gravity and its perturbations that play a significant role in the Oort cloud. Imagine the Oort cloud as a bustling city of icy bodies, each with its own trajectory. Now consider this. The city is not isolated. It's part of a vast cosmos, with neighboring stars and galactic forces. These external elements can exert gravitational pulls, causing perturbations or disturbances in the Oort cloud. Picture a nearby star passing through our galactic neighborhood. Its gravitational influence can tug at the icy bodies in the Oort cloud, altering their paths and velocities. Similarly, the Milky Way's tidal forces can also play a role. These forces result from the differential gravitational pull of our galaxy, which can stretch and squeeze the Oort cloud, causing further disturbances. But what happens when these perturbations occur? Well, these gravitational nudges can cause comets to shift from their stable orbits in the Oort cloud. Some may be flung out into interstellar space, while others may be sent hurtling towards the sun, becoming what we observe as long-period comets. These perturbations can also cause a chain reaction. A single nudge can send one comet spiraling into the inner solar system, which in turn can disturb others, setting off a domino effect of comets leaving the Oort cloud. It's fascinating to think about how these unseen forces shape the journeys of comets. From their tranquil home in the Oort cloud to their fiery passage near the sun, each comet's trajectory is a testament to the power of gravity and its perturbations. So remember, every time you see a comet streaking across the night sky, It's not just a spectacle of light and dust. It's a celestial traveler set on its path by the intricate dance of gravity. And behind that spectacle lies the complex interplay of cosmic forces that nudged it out of its icy home in the Oort cloud. Gravity, the unseen force shaping the journeys of comets. Why can't we just take a close look at the Oort cloud? Now that's a question. The answer is fairly simple, but also quite complex. You see, the Oort cloud is incredibly far away, even by space standards. It's located at a staggering distance of approximately 1 light-year from the Sun. That's about 8,000 times further than Pluto. Now imagine trying to spot a cloud of icy bodies that are likely not more than 20 kilometers in diameter from such a distance. Quite a challenge, isn't it? This is why direct observation of the Oort cloud is currently beyond our reach. But don't be disheartened. We aren't completely in the dark. Comets, those spectacular celestial travelers, provide invaluable indirect insights into the Oort cloud. By studying comets, we gain a better understanding of the composition and structure of this distant reservoir of icy bodies. The Oort cloud, a distant mystery waiting to be unraveled. The Oort cloud does more than just house comets. It's a crucial part of the solar system's dynamics, with profound influence on the distribution of comets and other small bodies. Imagine it as a celestial supply store, restocking the solar system with fresh comets as needed. The Oort cloud's extensive reach and substantial mass allow it to hold sway over these icy travelers, influencing their orbits and occasionally sending them on a journey towards the Sun. But it's not just about comets. The Oort cloud also plays a part in the larger cosmic dance, interacting with nearby stars and the galactic tide. Its gravitational interactions can nudge objects into new paths, contributing to the ever-changing landscape of our solar system. So when we talk about the Oort cloud, we're not just talking about a distant cloud of comets. We're discussing a key player in the dynamism and evolution of our solar system. The Oort cloud, an influential player in our solar system. What have we learned about the Oort cloud so far? The mysteries of the Oort cloud have captivated scientists and space enthusiasts alike. And while it remains largely unobserved directly, our understanding of it has been shaped by various investigations and discoveries. One of the most significant investigations into the Oort cloud has been through the study of long-period comets. The orbits of these icy bodies, which take them on long elliptical journeys through our solar system, suggest a distant origin point, which has been theorized as the Oort cloud. By studying the composition and trajectories of these comets, scientists have gained indirect insights into the Oort cloud, its structure, and its role in our solar system. Moreover, the discovery of Sedna in 2003, a minor planet with an extremely elongated orbit, has further supported the existence of the Oort cloud. Sedna's peculiar orbit and distant aphelion, the point in its orbit farthest from the Sun, suggests that it resides in the inner Oort cloud. This discovery has provided valuable clues to the structure and extent of the Oort cloud. Telescopic observations and space missions have also played a crucial role in our understanding of the Oort cloud. The Wide Field Infrared Survey Explorer, or WISE, has been instrumental in identifying potential Oort cloud objects. Additionally, the upcoming launch of the James Webb Space Telescope, touted as the successor to Hubble, holds promise for further observations of the Oort cloud and its inhabitants. The Pioneer 10 and 11 and Voyager 1 and 2 spacecrafts, while not directly aimed at the Oort cloud, have ventured into the outer regions of our solar system, providing valuable data about the environment where the Oort cloud is thought to exist. As these spacecrafts continue their journey, they may yet reveal more about this mysterious region. In the realm of theoretical research, computer simulations have provided insights into the formation and evolution of the Oort cloud, contributing significantly to our current understanding of this distant celestial sphere. The Oort cloud, a realm of discovery and exploration. Could the Oort cloud hold secrets to life? This far-flung icy frontier may indeed have profound implications for astrobiology. Let's delve into this fascinating possibility. The Oort cloud, with its vast store of icy bodies, could have played a role in the delivery of water and organic compounds to the inner solar system. As comets from the Oort cloud make their dramatic entrances into the inner solar system, they bring with them constituents that are essential for life as we know it. These icy messengers may have been crucial in seeding our planet with the ingredients for life during its formative years. Furthermore, the study of these comets and their origins in the Oort cloud could provide valuable insights into the conditions that were present in the early solar system. These conditions, in turn, could shed light on how life may have originated, not just on Earth, but potentially on other planets as well. The Oort cloud, possibly a crucial piece in the puzzle of life. What does the future hold for the exploration of the Oort cloud? Today, we've journeyed through the icy realms of the Oort cloud, the birthplace of long-period comets, and the outermost boundary of our solar system. We've dug into its formation, dived into its structure, and explored the unique characteristics of the comets it births. We've differentiated between short and long-period comets and examined how gravity and perturbations influence this distant cloud of icy bodies. The Oort cloud, with its vastness and remote location, presents significant observational challenges. Yet, it plays a pivotal role in our solar system's dynamics, and its study has led to intriguing scientific discoveries. Its potential role in astrobiology, particularly in the delivery of water and organic compounds to our inner solar system, makes it a fascinating subject for future exploration. So let's keep our eyes on the stars, stay informed, and eagerly anticipate the mysteries that future missions to the Oort cloud may unravel. The Oort cloud, a frontier of the unknown, beckons us to explore and understand the mysteries it holds.